So hello everyone and welcome back to our Python programming course. In the previous video we learned about module and packages and saw how they help us organize the reuse code across multiple files. Today we are going to learn one of the most powerful programming concept, object oriented programming or OOP. So many modern applications such as banking system, e-commerce website, games and mobile apps are built using OOP principles. By the end of this lesson you will understand what classes and objects are, how to create them, how construct work, and how method help object perform tasks. Let's get started. So the first slide is object oriented programming, OOPs in a Python. So think about a real world object like a car. Every car has certain properties such as color, model and speed. A car can also perform action like starting, stopping and accelerating. In programming we can represent real world object in the same way. We creating class that describe the object and then create objects from the class. The approach is called object oriented programming. It helps us build programs that are organized, usable and closer to real world thinking. So the second slide is learning objects. By the end of the lesson you will able to understand object oriented programming, learn about classes and objects, create object from classes, understand construct using init, learn instance variable and methods, write simple OOP based Python programs. Let's get started. So the third slide is what is OOP? Object oriented programming is a programming style based on objects. An object represents a real world identity, so the class acts like a blueprint for creating objects. Think about building a house. Before construct begins, an architect creates a blueprint. Using the same blueprint many different houses can be built. Similarly, one class can create many different objects. For example, a student class can create many student objects: student 1, student 2, student 3. Each object can have different information but all follow the same blueprint. So the fourth slide is class and objects. Let's create our first class. So class student pass student 1 equal to student. Here student is the class, student 1 is an object created from the class. Now let's add a variable. So class student name equal to alias, student 1 equal to student, print student dot name. So the answer is alias. The object access that variable using the dot operator. Classes describe what an object should contain, while object are actual instance created from that class. So the fifth slide is a constructor init. So most of the time we want each object to store different information. For that we use a constructor. In Python the constructor is written using the init method. So the for example is class student, def init self name, self dot name equal to name, student equal to student, alias, print student dot name. So the output is alias. Let's understand this code. The init method runs automatically whenever a new object is created. A self keyword refers to the current object. Here the value alias is stored inside. Every object gets its own copy of the data. Sixth slide is instance variables and methods. A class can contain both variables and methods. Variable store data. Methods define the action an object can perform. So the class student def init self name, self dot name, def display self print student self dot name, student equal to student, alias student dot display. So the output is student alias. Here name is an instance variable and display function is a method. Methods allow object to perform a specific task. So the seventh slide is a multiple objects. So one of the biggest advantage of OOP in that one class can create multiple objects. So the class student def init self name equal to name. So the so the student in 1 equal to student alias, student 2 is student Bob, student 1 dot display, student 2 dot display. So the output is student alias, student Bob. Notice that both objects use the same class but each stores different data. This avoid code duplication and makes program much easier to manage. So the eighth slide is benefits of OOPs. So let's look at some advantage of object oriented programming. Code reusability. So we can use the same class to create many objects. Better organization. Relate related data and function state together inside a class. Easy maintenance, updating one class automatically affects all objects created from it. Real world modeling, oops, makes it easier to represent real world identities such as student, employees, vehicles, and products. Scalability, large software projects become easier to expand and maintain. These advances make OOP one of the most popular programming approaches today. Slide 9 equal to complete example of this. So let's create a practical program. Class rectangle, def init self length width. So self dot length equal to length, self dot breadth equal to breadth. Area, def area self return self dot length star self dot breadth rect equal to rectangle 5 comma 8. Print area equal to rect dot area. So the output is area equal to 40. Here the constructor stores the rectangle's length and width. The area method calculates the area. The object calls the method using the dot operator. Some common mistakes beginners make are forgetting to write self as the first parameter of instance methods, misspelling init, creating an object without providing the required arguments. Always double check these points while writing oops programs. So the last slide is summary. So let's quickly revise today's lesson. We learned that object oriented programming is based on classes and objects. A class acts as a blueprint while objects are the actual instance created from the blueprint. We learned how to construct and initialize object data automatically using the init method. We also understand the role of self-instance variable methods and saw how one class can create multiple objects, one with different data. Finally, we explored the advantage of OOP, including code reusability, better organization, easier maintenance, and real-world modeling. Object-oriented programming is a fundamental concept in a Python and many other programming languages. As you build a larger application, you will use OOP extensively to write clean, modular, and maintainable code. In the next video, we will learn about exception handling in Python. You will discover how to handle error gracefully and prevent your programs from crashing unexpectedly. Thank you for watching this lesson. Keep practicing, experiment with creating your own class and an object. I will see you in the next video. Happy coding.